A few weeks ago, I sat down with a retired Boeing engineer who had spent 40 years on the factory floor. He wasn't interested in talking about aviation. Instead, he was staring at a printout of the 2025 industrial data sheets, his hand slightly trembling. He pointed to a single bolded figure, $1 trillion. That is China's recorded trade surplus for the year. At first, he tried to rationalize it, muttering about currency manipulation and subsidies, the usual comforts of a man from the old world. But then his expression shifted from denial to a sort of quiet, hollowed-out realization. He started describing a video he'd seen of a new humanoid robotics plant in Dongguan. He didn't focus on the robots themselves, but on the societal granularity of the scene. How thousands of these machines were seamlessly integrating into the production line of solid-state batteries, controlled by a handful of engineers who looked more like conductors than managers. "We used to think the body didn't matter," he whispered. "As long as we owned the brain, we were wrong." That $1 trillion surplus is not just a ledger entry. It is the ultimate autopsy report on the physical world. It reveals a chilling metamorphosis, where the East didn't just win a trade war. They occupied the very infrastructure of the future. While Western boardrooms were obsessed with the abstract calculus of stock buybacks and de-risking slide decks, a supply chain fortress was being built out of silicon and steel. The contradictory reality we face now is startling. We celebrate our digital AI revolution, yet we find ourselves increasingly unable to manifest that intelligence into physical form without a permit from the East. We're witnessing the death of the financier's dream and the rebirth of the engineer's empire. As we dissect these numbers, we have to ask, what happens to a civilization that keeps the blueprints but loses the ability to touch the world?
It's a pretty sobering opening, because it forces you to confront a reality that's been building for decades, but somehow it feels like it just arrived overnight.
Right.
And when you look at the reports we have here, the industrial analysis from Civil Mentors, the raw data from the World Bank, that engineer's reaction, it isn't melodrama.
No.
It's a recognition of a deep structural shift.
Right.
We're looking at a data set from late 2025 that suggests the world we thought we lived in, it's gone.
That old model of the West designing and the East assembling, gone. And we have to start with that headline number. It's the anchor for this whole deep dive, $1 trillion. You know, in the world of global finance, we get kind of desensitized to big numbers, trillion-dollar deficits, market caps. We hear it all the time.
Sure.
But a trade surplus of that size it feels physically different. It implies a level of industrial output that's just, it's hard to wrap your head around.
It is hard to wrap your head around. And it's not just a big number. It's historically anomalous.
Anomalous how?
Well, the data from the close of 2025 puts the surplus somewhere between $1 trillion and $1.2 trillion.
Wow.
And to really get the gravity of that, you have to look at it as a percentage of global GDP.
Okay.
We haven't seen a single nation hold that kind of dominant position since the United States in the mid-1940s.
The 1940s.
Yeah. We are talking about a World War II level of industrial imbalance.
That is a terrifying comparison, mostly because you think about what the U.S. was producing then, tanks, planes, the whole arsenal of democracy.
It's exactly.
But I want to push back on the composition of this number. For the last, 20, 30 years, a Chinese trade surplus meant volume, not value.
Well, margin goods, yeah.
Right. Shipping containers full of fast fashion, plastic chairs, cheap electronics. If this $1 trillion is just a mountain of Temu packages, does it actually matter strategically? Or is it just consumer noise?
That is the single most important question to ask, and the answer is in the customs data.
And what does it say?
It says the era of low-margin consumer goods driving the surplus it's basically over.
Really?
That share of the pie is flatlining. It's even shrinking. What we're seeing now is a surplus driven almost entirely by high-value capital goods.
Capital goods.
The reports call them the new three. And by 2026, the new three are electric vehicles.
Okay, that makes sense.
Advanced energy storage, so the new lithium-ion and especially the solid-state batteries.
Right.
And green energy infrastructure, wind turbines, solar components, that kind of thing.
So wait, while the West has been setting these, really aggressive climate goals and talking about a green transition, the East has just quietly monopolized the machinery you need to actually do it.
Precisely. They aren't just selling the car. They're selling the battery factory and the wind turbine to charge the car. The means of production.
The whole stack.
The whole stack. And there's a nuance here with semiconductors that I think gets missed in the mainstream tech press.
No one.
All through 2024, 2025, the entire Western world was obsessed with NVIDIA. H100s, B200s.
The bleeding edge chips.
Yeah.
The 3-nanometer stuff for training AI models.
Exactly. The brains, right. The logic was, if we control the smartest chips, we control the future.
That was the logic.
But the trade data shows something else was happening. While the West was focused on the absolute ceiling, China reinforced the floor.
The floor? What do you mean?
In late 2025, Chinese exports of legacy chips jumped by nearly 25%.
Legacy chips? That sounds old. Unimportant.
It's a terrible branding term because it implies they're obsolete, but they're not. These are 28-nanometer chips and above. They are the workhorses of reality.
The workhorses?
They're the chips in your car's braking system, your microwave, the medical devices in a hospital, the power management in a wind turbine. You don't need a supercomputer to roll down a car window. You need a legacy chip.
I see.
So by cornering that market, they haven't just cornered the dumb chips. They've cornered the chips that allow the physical world to function.
Which brings us back to that term from the opening. The supply chain fortress. It sounds defensive, maybe even offensive, a siege capability.
It's more than just buying products. It's a fundamental reliance on the root infrastructure of modern life.
And Warwick Powell, one of the policy experts we looked at, he had a fascinating point about this fortress idea.
He did. He argues the West is completely misreading the mechanics of this surplus.
Also.
So yes, the world is buying more finished goods from China, but look at the inputs.
The raw materials.
China is importing massive, record-breaking volumes of raw materials. Iron ore, copper, gold, bauxite, lithium.
So they're just vacuuming up the periodic table?
They're vacuuming up the raw earth. And here's the economic trick of it.
Okay.
Global commodity prices, they fluctuate, right? So the dollar value of their imports might look flat on a spreadsheet.
Sure, prices go down. The value stays the same even if volume goes up.
Exactly. But the physical volume, the sheer tonnage of matter going into Chinese ports is enormous. They are converting raw matter into high-tech capital goods at a scale that is creating a kind of gravitational pull on the global economy.
It's like a black hole for raw materials?
Yes.
And a white hole for finished infrastructure.
That is a very, very accurate way to visualize it. The fortress isn't just the factory, it's the whole ecosystem. It's the fact that the battery, the chips, the sensors, the glass, and the solar panel you use to charge your Chinese EV.
We're all coming from the same place.
All from the same integrated industrial web, which is completely different from how Western supply chains have fragmented over the last 30 years.
You know, speaking of that integrated web,
Yeah.
that gravitational pull, I want to pivot to something I saw recently because it really grounds this abstract economic data into something you can see and feel.
Okay.
It's one thing to talk about $1 trillion, but it's another to see it in action.
Yeah.
I saw this video. It's from a workshop in Shenzhen, and it felt like a glimpse into a different timeline. The camera follows this assembly line veteran, a guy named Lao Wang. He spent 30 years perfecting the manual calibration of hydraulic valves.
Okay, so a master craftsman, the kind of knowledge you can't teach from a book.
Exactly. A guy with oil in his pores.
All right.
But in this clip, Lao Wang isn't holding a wrench. He's walking side by side with this sleek humanoid robot.
Wow.
And it's mimicking his exact movements with this uncanny grace. And the kicker is, this robot wasn't an import. It was a native of the Pearl River Delta.
So all the parts were sourced locally?
Every sensor, every motor, the AI brain itself, all from factories within a 10-mile radius. And watching that, I realized, while we're treating AI like this digital ghost, over there, it's been given a physical body.
And not just one?
No. They claimed 80% of the global market by 2025. You feel this unease about humans being replaced, but watching Lao Wang, he was proud. He was training his mechanical successor.
It's a different mindset.
It felt like a strategic reality. This is digital intelligence finally getting the arms and legs it needs to reshape the physical world.
That image of Lao Wang and the robot, that is the perfect visualization of this next phase. It's what the Carnegie Endowment Report calls embodied AI.
Let's unpack that term. Because AI has become such a buzzword, it's almost meaningless.
Right.
We've spent the last few years obsessed with generative AI, ChatGPT, Claude, things that live on screens and make text or images. How is embodied AI different? Is it just ChatGPT in a metal suit?
No, it's a crucial distinction. It's the difference between the virtual economy and the real economy.
Right.
Generative AI or digital AI, it handles information, it writes code, summarizes emails, creates art. Embodied AI handles matter.
Matter, physical stuff.
It uses something called large action models. It has to perceive the physical world, gravity, friction, weight, texture, and then manipulate it. in real time.
And the turning point for this, according to the sources, was what they called the DeepSeek moment.
DeepSeek R1 release in early 2025.
Which was their big software breakthrough.
It was. But what made it a moment wasn't just that the software was good. It was that Chinese manufacturers immediately started integrating that reasoning capability into hardware.
So while the West was building better chatbots to write marketing copy,
China was giving those chatbots hands to weld cars. The government's push has been explicit. Integrate AI into manufacturing, logistics, agriculture, the real economy.
you see that in the Zeekr factory example from the reports. That seemed like a perfect illustration of this.
It is. At the Zeekr EV plant, they deployed these UB-Tech humanoid robots. And they weren't promotional dancers or tech demos.
Right, they were on the line.
They were on the line, lifting heavy boxes, assembling door panels, performing quality checks right next to human workers.
And then there was the Walker S2 robot.
Yes. Even more significant, maybe.
That's the one that changes its own battery, right?
Yes. And just think about the implication of that for a factory manager.
No downtime.
0. If a robot can autonomously go to a charging station, swap its own battery, and go back to work, you've unlocked genuine 24-hour manufacturing. No human intervention needed.
No shift changes, no lunch breaks.
You don't even need to keep the lights on. The machine maintains itself.
The dark factory concept is actually here.
It's here. And that statistic you mentioned, 80% of the global humanoid robotics market by 2025. That doesn't happen by accident. It happens because of what the Boeing engineer called societal granularity.
Right, that phrase. What does it actually mean in practice?
It means density, proximity.
Yeah.
If you're a robotics startup in Silicon Valley, you need a custom motor. You order it from maybe Ohio, more likely Shenzhen. It takes 2 weeks.
And if it's wrong,
You send it back, another 2 weeks. In Shenzhen, the factory making your motors is down the street. The company coding the algorithm is 2 blocks away. The battery supplier is next door.
the iteration cycle is measured in hours, not weeks.
Correct. This is what they call the productive physique. You have this incredible density of suppliers and talent that just allows for rapid, explosive evolution.
So if a prototype fails on Tuesday morning,
You have the redesigned part by Wednesday afternoon. This lets them build synthetic, labor-programmable physical labor at a speed nobody else can match.
and you have to look at the demographics here. China has an aging population. The workforce is shrinking.
Right, so this isn't just some cool tech trend for them.
No, it's a survival strategy.
It ensures their industrial output can keep growing, even as the human workforce declines. They're building a labor force that doesn't age, doesn't get sick, and never retires.
Okay, so you have the manufacturing base, the trillion-dollar surplus, and now the robotic workforce. But you have to put that capability to work on something.
You need a stage for these actors, yes.
And this brings us to the actual physical landscape of 2026,
Yeah.
the mega projects. I was watching a vlog from a European architect, and he was just stunned.
About what?
He was standing on the coast of one of these new mega projects, and he couldn't believe it had gone from blueprint to finished structure in under 2 years. He compared it to a bridge project in his own country.
Let me guess. Stuck in committee.
Stuck in a decade of procedural delays, environmental litigation, and budgetary gridlock. And his point was, this isn't just about who has more concrete, it's about physical state capacity.
The ability to actually do things.
Right. One side is building the substrate for the next century, while the other is still filing paperwork. It feels like the end of the era of soft power and the return of a world defined by the sheer raw ability to build.
That architect's envy. It's completely backed up by the hard data. The Civil Mentors report calls 2026 a year of convergence.
Convergence.
It's the year where a huge number of these long-term 15-year plans all hit completion at the same time.
So let's look at what's actually being finished, because this isn't just we paved a road. The tech is incredible. Let's start with the trains, the CR450.
The CR450 is a total game changer for logistics, for labor markets. We're talking commercial service at 450 kilometers per hour.
450, for context, what are the fastest trains in Europe or Japan running at?
300, maybe 320 kilometer hour. And China was already at 350. Now they've added another 100 on top of that.
I mean, how do you even keep a train on the tracks at that speed? The physics must be a nightmare.
It is. And it's not one big breakthrough, it's thousands of little ones. They had to redesign the pantograph, the arm that touches the overhead wire, because the aerodynamics are totally different. New vibration controls, new braking materials.
That's a whole new machine.
A whole new system. They even had to solve for the noise, because at that speed, the air pressure wave you create can be a structural problem for tunnels.
And the impact isn't just, I get to my meeting faster.
No, it reshapes the country. A 1,500-kilometer trip, think New York to Florida, that becomes a same-day commute. It completely replaces domestic air travel.
Which frees up airspace for it.
Long-haul logistics, freight. It effectively shrinks the country.
And speaking of transport hubs, there's the Jiangnan International Airport.
Right. Built on reclaimed land off the coast of Xiamen, facing Taiwan.
And the scale is just
massive. 45 million passengers a year to start. That's about the size of JFK or Heathrow, but built from scratch on an artificial island.
And it's not just for tourists.
No. It's designed explicitly for cross-strait, trade, and regional logistics. It's a physical assertion of economic gravity in that region.
Okay, so you've got the transport, but you can't run robots and super trains without power. And the Shuangjiankou hydropower station, that caught my eye.
As it should. It's 315 meters high.
Which is taller than the Eiffel Tower.
Taller than the Eiffel Tower, the tallest dam in the world. But its purpose is what's really unique. It's designed to act as a battery for the Yangtze River.
A battery? How does a dam act as a battery?
It manages flow. A few years ago, the region had terrible droughts. Factories in Sichuan had to shut down because the hydro plants dried up.
Right, I remember that.
This dam is designed to store massive amounts of water during the wet seasons and then release it strategically during the dry seasons. It flattens the curve of energy generation. It's an engineering solution to climate vulnerability.
And then alongside this mega dam, you have something much smaller, but maybe even more revolutionary. The Linglong 1.
The world's first land-based commercial small modular reactor, an SMR.
We've been hearing about SMRs in the West for a decade. It's always the future of nuclear, but they actually built one and turned it on.
They did, and the logic is brilliant. The problem with nuclear in the West is that every plant is a bespoke, one-off construction project. They go billions over budget and take 10 years.
Right.
The Linglong 1 is a factory approach. They build the reactor modules in a factory, truck them to the site.
Like Lego blocks.
Exactly. You can assemble one in under 5 years. You can put them in an industrial park, on a remote island, next to a desalination plant. It decentralizes nuclear power.
And finally, the renewable bases. The solar and wind farms in the desert. The scale is hard to comprehend.
Hundreds of square kilometers of solar panels. But the real tech isn't the panels. It's the wires.
The transmission lines.
They're using 1,100 kV ultra-high voltage lines, UHV, to shoot that power from the western deserts all the way to the factories in the east.
And why is UHV so important?
Resistance. If you try to send power 2,000 kilometers over standard lines, you just lose a huge chunk of it as heat. It's incredibly inefficient. UHV lines are like super highways for electricity with very low loss.
It solves a problem we have in the West.
It solves the problem that plagues the US and Europe, where you can generate green energy in windy, sunny places, but your grid is too old and fragmented to actually get it to the cities. They built a national supergrid to move the energy.
Which brings up the big question.
Yeah.
How? How are they building all this so cheaply and so fast?
No.
I mean, high-speed rail there costs, Rhett, 2/3 of what it costs anywhere else?
Sometimes half, yeah. It comes down to a few factors. First, standardization. The World Bank pointed this out. They don't redesign every bridge. They standardize the bridge beams to 24 and 32 meters. That's it.
And they just mass-produce them.
They build a temporary factory right next to the rail line, cast the beams, drop them in place, and then just move the factory down the line. It's an assembly line for the infrastructure itself.
And the policy side of it.
It's pilot first, scale later. They let different regions experiment with policies. Whichever one works best gets scaled up nationally.
But there's a harder edge to this, too. The legal environment.
There is. In the West, projects are bogged down by what you could call consultant bloat.
The army of lawyers and impact studies.
Exactly. NIMBYism, not in my backyard, can stop a project for 20 years in the US. In China, they prioritize directive efficiency.
Meaning if the state says a dam is needed for national energy security.
The dam gets built. The rights of an individual landowner are secondary to the strategic goal of the state.
It really feels like two different operating systems for civilization. A philosophical divide. You know, I heard this story about a young engineer in Shanghai named Lee. He turned down a massive offer from a private equity firm in London. Now, that's usually the golden ticket.
Yeah, go to London, work in finance.
But he stayed in Shanghai to work at a plant that makes equipment for solid-state batteries. And for him and his peers, this industrial worship we've been reading about isn't just a macro trend, it's a personal philosophy.
How so?
He said that in his culture, a perfectly synchronized robotic arm is seen as a higher achievement than a complex financial derivative. To him, the trillion-dollar surplus isn't a number. It's physical proof that his society values making over managing.
That phrase, making versus managing, that cuts right to the core of the governance issue.
It does.
One of the sources we reviewed put it perfectly. It said, in China, governance is treated as an engineering problem. In the West, governance is treated as a messaging problem.
Oof. That stings a little, but it feels accurate when you look at the Western response to this surplus. The tariffs, the de-risking policies, the sources call them defensive spasms.
It's a harsh assessment. But the argument is that these political recoils are happening because the physical reality is just becoming impossible to ignore anymore.
And Warwick Powell, he had a really sharp insight here. He warns the West is fighting yesterday's war.
You mean like the trade war with Japan in the 80s?
Exactly, the Plaza Accord. The U.S. forced Japan to appreciate the yen to make their exports more expensive, and it worked. It crushed them.
So the assumption is we just do the same thing now. Force China to appreciate the RMB, problem solved.
Why wouldn't it work? Stronger RMB, Chinese goods get more expensive for us, we buy less. Simple.
Right. Powell argues it's not that simple anymore because China is the supply chain fortress. Remember all those raw materials they import?
Right. Iron, copper, oil.
If the RMB gets stronger, what happens to their purchasing power for those things?
Increases. They can buy more for less. Their input costs go down.
Exactly. So a stronger currency could actually lower their production costs. It might make them even more competitive, not less.
So the old financial weapons could actually backfire.
It could misfire, yes. And this leads to what Powell calls the copium narrative.
The copium narrative.
It's politically easier to say China is cheating or has overcapacity than it is to admit that their industrial system might simply be more efficient.
Because admitting that would require a level of introspection that's politically very difficult.
Very difficult to handle.
Yes, this feels like a true civilizational divergence. On one side, you have a system betting it all on financialization. Stock buybacks, the service economy, digital apps, whatever keeps the stock price high.
And on the other side,
a bet on physicality. Steel, silicon, watts, robotics.
And looking at this 2025 and 2026 data, that bet on physicality looks like a survival strategy because in a crisis, a pandemic, a war, a climate catastrophe, you can't eat a derivative, you can't take shelter under a software license. The ability to actually make things, masks, ships, batteries, dams, that's the only metric that matters when the chips are down. That industrial worship, it isn't just propaganda, it's a recognition that the physical world is the final arbiter of reality.
We have covered a massive amount of ground today. We started with a $1 trillion number that shocked an old Boeing engineer.
Right.
But as we peeled it back, we found something much bigger. We found a shift from low-tech toys to high-tech infrastructure. We found a labor revolution where robots are capturing 80% of the market. And we found a nation building dams taller than skyscrapers and trains that literally outpace airplanes.
And all of it, every single piece, points back to that supply chain fortress. The surplus is just the smoke. The fire is the complete domination of the industrial process, from raw material to finished product.
It leaves us with a very specific, and I'll be honest, a pretty provocative final thought. If you take one thing away from this deep dive, let it be this. We are witnessing the end of the era of soft power and the return of a world defined by the sheer, raw ability to build. The autopsy of the 2025 data reveals a simple, brutal conclusion. The future belongs to those who command the physical world.